Well, good afternoon, bom pomeriggio, boa tarde em português. So we're going to start our afternoon session of the day 2. And day 2 is the Science for Coastal Resilience theme. And we're going to start our afternoon session with a speech from Professor Giovanni Coppini. After Giovanni Coppini presentation, we'll have a roundtable on innovations in coastal monitoring and forecasting with Viviana, Piermattei, Renata, Archetti, which will be online, Alessandro, Pititto, Stefano Cazu, and Daniela Yazilo. So first, I'm going to present Professor Giovanni. Professor Giovanni Coppini has a PhD in environmental science from the University of Bologna. He's a technologist at IMGV, specializing in operational oceanography since 2003. He has led oil spill forecasting and represented IMGV and CMCC in various European projects, including MyOcean. As the Emergency Response Office Manager for Mongoose, he co-chairs the initiative and directs the Ocean Predictions and Applications Division at CMCC. His expertise focuses on oil spill emergency management, and developing environmental and climate change indicators. So thank you for being with us, Professor Giovanni. So Giovanni is going to talk about solutions for coastal resilience and adaptation.
Good afternoon, everybody. It's really nice and a pleasure to be here. And yes, it's a joint work of CMCC and University of Bologna and many more partners that you will see. So the idea is to propose science-based solutions for the coastal environment. And the first attempt is to understand and describe that in the coastal environment, or knowledge that in the coastal environment, many complex problems interact and each other among them, and interact often in a non-linear way. So it's really complex to tackle and face coastal problems and solve them. And we deal not only with the physical problems, but also with environmental problems such as extreme events, but also environmental problems. And then often there is a lack of data, and you will see these problems interact, like coastal erosion and water quality. And then also we need to look to the governance and how to integrate the different needs of society and environment in the coastal environment. So one first answer is to get together and try to understand the problems together, identify the problems, and then find solution. Within the UN Ocean Decade, and together with the DCC on coastal resilience, we have launched Global Coast, which is a cost predict initiative that put together hundreds of experts worldwide to create a global replicable solution and standards and application to enhance coastal resilience for both natural and built environment. And the idea is to develop a set of solutions through the pilots information. You will see what are the pilot sites, and the products from the pilot sites will go through the cloud, and then will be used to deploy services and solutions for the pilots themselves and the external world of users. And this approach should allow to overcome different problems and barriers that today prevent to develop solution for coastal resilience. And we should develop replicable solutions so that they can be deployed in many places in the world, and also ensure the accessibility of the solutions. And the cloud should be really the breakthrough towards this equitable accessibility of the solutions. Our network today in Cost Predict and Global Coast is about 130 pilots all over the ocean, and somewhere there in the Adriatic Sea you will find the Adriatic Sea and Rimini and many places also in Italy that are participating to this network. And we also engage, it's not only a research network, because we have engaged stakeholders and users in the specific pilots. And of course, if you can understand, if we are able in the next years to demonstrate that our solution jointly developed will be replicable everywhere in these pilots, then we will probably achieve our goal. We have analyzed which are the main problems of the coastal ocean together with this community. So they've answered, each pilot has answered to a survey, and we have identified the disaster risk reduction and the impact of climate change as the two major or two highest priority problems or challenges here called impact areas in the global coastal ocean, in addition to the others not less relevant, still important problems. Now, where are we today? Today we are able, you have seen also in our beautiful videos, we are able to describe the digital ocean. So we are able to reproduce from the global to the local scale the physical environment. Here are examples of currents described as much as possible accurate by numerical model. This is the example of Fiumicino, but somewhere in the screen you can find also Rimini. So this is, there are many places today described at such resolution and accuracy, even if it's not a global, because then you need to downscale in the local position. And these allow to move progressively from a digital ocean to a digital twin. The digital twin, as Lorenzo was nicely described this morning, is the place where you can try, like a metaverso, you can try solution, you can test solution, and you can take decision or informed decision. In this case, we have asked to our digital twin where is the optimal place in the Lazio coast to restore the ecosystem. Optimal in the sense that the ecosystem service of Posidonia, which is one of the ecosystem services, is dumping the wave, so reducing the wave impact on the coastal area, is not homogeneously distributed. You see that the maximum is in this area, in the blue area. So this means that if I'm a municipality or a port authority that I want to restore the ecosystem, if I want to maximize my investment, I start from this area through also very costly initiative. I mean, the cost of 1 square, I mean, it costs a lot. I don't want to give a number, but you can imagine that you need to deploy the plants with divers and so on. So you need to optimize this cost. It's much important to also assess the risk from the global to the coastal area. So we don't only have to describe properly in the digital twin, but we need also to understand which is the risk we are going to face today and in the future. Here is the results of a paper that show which are the areas that will be progressively more and more at danger of extreme events, in this case storm surge. And so the idea is that we need to enhance, and I will show you some example afterwards, we should enhance the capacity of risk assessment. We should innovate through the digital twin the way we interact with the user community and the society, and we should also expand the cloud-based computing capacity infrastructure to make all these solutions interoperable. An example for the Adriatic Sea, which is a complex modeling system that has been developed by many of us, we have shown that the river and the ocean circulation will change in the Adriatic Sea in the next year. The marine heat wave will become more intense and more frequent. Lorenzo has shown in a paper that the Adriatic Sea probably will be more oligotrophic, so more poor, most probably because the river will release less nutrients in the ocean. And also you can see that there is a spatial variability in the sea level rise. So in addition to subsidence that is not homogeneously distributed, so this information needs to reach the stakeholder and the users. Now, the system, the modeling system today are capable of modeling and forecasting extreme events. This is an example of the Mediterranean Copernicus forecasting system in Venice Lagoon, augmented by very high resolution models. So these products are available in real time to the users. They need to be used and they increase, of course, resilience. In addition to that, what we are preparing, for instance, for Venice is the capacity of running the high resolution sea level modeling with and without the MOSE opening. So here you see that the model and the tide gauge, the model and the observation are very good, but in addition inside, if we use the model with the MOSE inside, we can open and close the MOSE and you can very nicely reproduce the sea level inside the lagoon. So where you see that it would have been like that without the MOSE in the model, it's realistic lowering, and the same has been shown by Lorenzo when you use the coastal sea level inundation, the coastal inundation system. So these tools are progressively more and more available to the users. I'm re-showing how the model can be used in the digital twin to plan for waves, but also to plan where the currents are optimal for, bottom currents are optimal for restoration. So you need to take into account the complexity of the environment to optimize where you want to restore or start restoring the ecosystem. Sediment transport as well, it's a key problem, or coastal erosion is a key problem in the coastal area. These are two examples where our model is compared to satellite monitoring of sediment concentration, and a more applied or actionable science is when we are in the port of Fiumicino here, and we are modeling what if happen if I enlarge the harbor. Is it coastal erosion changing? Yes, it's changing. And you see that the blue area is going to be eroded, the red area is going to be accumulation. So you might want to design in an optimal way the harbor so that, of course, engineers does this since decades, but the opportunity today is that the modeling capacity and the observational capacity has reached a level that makes this modeling very realistic, hopefully avoiding errors, let's say, or problems in the future. I want to finish, or almost finish, with some worldwide example. This is an example of an early warning alerting system. The dots are measurements, is a sea level sensors. And here you see an example of a sea level sensor, which is a cost effective. As Antonello Bruschi was saying this morning, this is not a tide gauge or very sophisticated, but you can put many of them and then you can cover a very wide area. This is Savannah, it's a very wide area. So you can monitor how in this case, the sea level, actually the storm surge and the coastal inundation is changing in space and time. So you add information. We have seen already the need of developing solution for climate adaptation in terms of how the ecosystem will change. Pollution is another problem of coastal that interact with climate. So we need to risk map map the risk of pollution in the coastal area. And we need to use our model to plan coastal restoration. In this case is an example in the Northern Adriatic Sea, in the idealized world where we plant different patches of phanerogame, and then we simulate how the waves will dump down with different design. I will finish with the idea that Rimini could be a benchmark or a test case for our future projects, and especially the northern part of Rimini, as we have seen this morning by Professor Manini from Rimini municipality. So the northern part of Rimini has been, let's say, augmented through the project. The southern part has been transformed in a very nice beach pathway with protection. In the northern part remain the problem of coastal erosion, and the problem of coastal erosion, as you see, the beach is very thin. The beach is protected by rigid barriers. Here you see the defense. At the same time, there are possible problems of water quality. So we want to describe all these very complex systems, including the Marecchia River, in a digital twin, and then allow Regione Emilia-Romagna and then Rimini municipality to, I wouldn't say play, but change the environment and understand how these changes will affect the coastal system and which is the optimal way. So these are typical questions that could be answered in the future. I conclude saying that we can adapt. I mean, our ocean, we can change the way we live our ocean, but we need to be transformative. We need to, with our science need to be actionable, so used by the users and the society. We need to engage ourselves at a different level, from citizens to politicians. We need also to find a way of deciding how to change. So adaptation is a choice. It's not only rebuilding what it was in the past. So we need to understand that the system, the environment will not allow any option. We need to choose what we want. And we need also a lot of creativity to help us, because the standard solution will not work. And for sure, we need to make our science more and more accessible. So the cloud computing system probably is the best solution for the future. And this is part also of our new program at CMCC about called Global Coast as a New Frontier, that is starting now and probably will provide this solution for you. Thank you.
So now we have some minutes for questions to Professor Giovanni. Does anyone wants to make a question? Or otherwise we can go to the round table and start the debate. Yes? Okay, so let's go to the round table on innovations in coastal monitoring and forecasting. First, I would like to invite Viviana Piermattei. Thank you, Viviana. Viviana is a scientist at CMCC Foundation, leading the Advanced Observation Systems Research Unit in the Global Coast Ocean Division. She has a PhD in Ecology and Sustainable Management, specialized in low-coast oceanography instrumentation. Since 2023, she has focused on developing innovative sensors and observing systems, as well as advancing marine citizen science. Thank you. Then we have Renata Archetti online. Renata is a full professor. Renata is a full professor at the Department of Civil, Chemical, Environmental, and Materials Engineering. She holds a degree in Civil Engineering for the Environment and a PhD from the University of Milan, with expertise in coastal hydrodynamics. She has researched marine applications and oil spill pollution. Professor Archetti has authored over 200 publications and has served as a consultant in environmental protection and hydraulic engineering for over 25 years. She's online with us.
I'm here, okay.
Oh, hello, welcome.
Hi. Hello.
Then we'll have Alessandro Pititto. Hello, Alessandro. Alessandro is expert in blue economy. He's head of the international area at COGIA. With over 10 years of experience, he coordinates projects funded by various European institutions and agencies, including DG Mare, DG Move, DG Growth, and the European Parliament. Since 2013, he has served as the coordinator of EMODnet, Human Activities, a European network focused on observing and gathering data on the marine environment. We'll arrive. Should I present now? When they arrive. Okay. So we are waiting Stefano Casu and Daniela Yazilo. And when they arrive, we're going to... Oh, okay. Welcome. So Daniela has been working for more than 25 years in Planetech for the design and development of value-added services from Earth observation data. She coordinated projects for the national and international markets of spatial agencies, public administrations, defense, and the European Commission. She's in strategic development management for the Copernicus. Yes. Oh, I have more here. Just a second. Copernicus program, which has followed since its inception. She has worked in various fields such as research projects, promotion, and user uptake activities, training, and market expansion. So we're just waiting for Kazu, and we can start the debate. We're going to make a general question for all of you, and you can have some time to answer, around 3 minutes for each one. So the first question is, what are the essential ingredients of services in support of coastal resilience? Can you provide us examples and what is generally missing now? Oh, okay. Welcome, Dr. Kazu. Stefano Casu is head of the Technical Scientific Department and CIO, Chief Information Officer at Castalia. For over 20 years, he's responsible for research, development, and implementation of new technologies applied to marine anti-pollution activities. He's member of the Coordination Center for the National Emergency Service for Oil Spill Containment and Recovery at Sea, a service provided by Castalia on behalf of the Ministry of the Environment. Among various responsibilities, he coordinated on-site anti-pollution operations during the recovery of the Costa Concordia at Giglio Island. Thank you so much for your presence. So let's start. I'm going to repeat the question, which is a general question for the debate, to start and warm up the debate. So what are the essential ingredients of services in support of coastal resilience? Can you give us examples and what is generally missing now? So who wants to start?
Perini. Maybe she is missing.
I'm so sorry. Please welcome Perini, Miss Perini.
No. In this paper, your bio is missing. That's why she didn't read.
I'm sorry for that. Welcome, Luisa Perini, Difesa del Suolo. We'll retrieve your bio and we'll present you as soon as I have it here. Okay, so let's start, please.
I can start.
From me? Okay, thanks a lot. In my opinion, we need first a lot information. We need that this information are collected with a sound methodology, validated, and this data shall be collected on large area in harmonized way and available during time. Just to do an example, I presented just 1 hour ago in another roundtable a data set that in Planetech we are providing that is a map of soil imperviousness done in a strip of 20 kilometers of all Mediterranean coastline from 2018 to 2023 and some months also the 2024. This is an important data set because using this is possible to do not only spatial planning at regional level, but also some studies related to the coastal protection, and also to feed the models, hydrodynamical models, and a lot of other kind of activities. So it's important that these kind of data are available and are free for any kind of users.
Yeah, okay. Well, what is important for coastal resilience services, or what is missing and could be done? So first of all, today, the services that come from research are not accessible or very poorly used. So I think we need to work more and more through a co-design with users, because otherwise we do projects and projects and projects, and then the service is not, or the outcomes are not used. I think also the public-private partnership is important, is essential to, especially for the exploitation after the prototypes are developed, and also, I mean, both the research and the industry should grow on the concept that we can work together for providing these services. At the global level, what is missing is the accessibility of resources, especially for the global south. So we have a problem of computing infrastructure in the global south, and this does not allow them to really build coastal resilience. And that's why we think that, and we are working to develop a cloud system that should be accessible. Again, we need private and public partnership to make them really accessible and free of use, I mean, freely available to access the data that exists and the products that can exist and can be developed. So then I think the one additional component in the coastal area is that the in situ observing system in some areas it doesn't exist, especially again in the global south. And but even in Italy itself, there are areas undersampled. So we need to use satellite data plus low-cost sensor or citizen science information to then to map the extreme events, to map the coastal environment in general, at the accuracy that then will allow to use artificial intelligence and models to develop services. So, yeah.
As part of the industry that, as our presenter said, we provide, our company provides the oil spill response service for the Italian government and the marine litter collection. So we are involved in the protection of the sea, and we are the users of these technologies. And I totally agree. I mean, we need to push for a more synergy between the research and the industry to make those information available freely, if possible, and we need to build up a network. I mean, that can help us. I mean, to protect the environment and be more efficient in collecting the waste and the litter, and because now, I mean, the models are quite sophisticated and working, and they're very reliable now, but not available always. So that's important. I think that we should push for more synergy between the industry and research, for sure.
So I think we have a lot of actions to support the coastal resilience. For sure, we have to, maybe one of the action is the restoration, is related to the restoration. One other is we have to improve risk assessment and also risk monitoring. And another action is to improve the sustainability of the infrastructure, for example. And to do this, I don't want to repeat, but I see that there is a repetition, is that we need data. And we need real-time data also for early warning system, because we are speaking about extreme events and also monitoring of the effects of maybe both anthropic, so non-natural, but also natural impacts, because we have climate change. And we speak a lot about the health, and the safety for sure is primary for us, but all natural impacts have also impact on ecosystem, on marine ecosystem. So we need data, and the data must be available, and the data for sure are the first thing that the model need to be validated. So maybe we need, yes, both data and model available to support coastal resilience.
I think most of the ideas I had have been touched upon by the other speakers here. Anyway, since I am representing EMODnet, and I think everyone is familiar with EMODnet, but for those who don't know, EMODnet is the European Marine Observation and Data Network. I'll try to frame my points into what we do at EMODnet. So for us, first and foremost, the most important ingredient is, of course, data and data product. But we always stress the importance of finding accessible, interoperable, and reusable data. So fair data, in a word. And this data, of course, has to cover the open ocean, the coastal marine ecosystem, but also human activities in the ocean and around the coast, because the interaction, the land-sea interaction, is really crucial. Then I think it was Giovanni who mentioned satellite and in situ. I think it's quite an important point. For example, we could validate satellite data with in situ data, and in situ becomes especially important in coastal regions that have steep drop-off more than 200 meters, which is below the reach of most satellites, basically. And in situ here becomes crucial because it can be collected at any depth, and it also offers a more varied range of parameters. What else? Dialogue with all data collection efforts. So yes, public and private. At EMODnet, we, of course, we're in touch with all regional initiatives at governmental level, but we also always stress the importance of dialogue with industry stakeholders. The industry has a lot to offer for what we're doing now, and it's quite important to involve them, to incentivize them, to find mechanisms to strengthen this cooperation. Information has to be transboundary, of course, because yes, coastal resilience might be a local or national issue per se, but we live in a world in the ocean where boundaries are sometimes meaningless, so we do need transboundary information, absolutely. Information on multiple timescales, yes, especially for longer term prediction of sea level rise, that is crucial. And lastly, in certain cases, for us, it's particularly important to have some near real-time information for certain parameters to be able to, you know, for early warnings and so on. That's it from my side.
Thanks.
I'm going to introduce you now. Sorry for our mistake. So I'm going to introduce Luisa Perini. She is part of the soil defense area for the Emilia-Romagna region. She holds a degree in geological science from the University of Bologna. Dr. Perini specializes in the development and management of the Mare Costa information system and conducts studies aimed at mitigating coastal risks, contributing to effective coastal zone management and environmental protection strategies. So thank you.
Thanks a lot. So the other person already stressed again against the necessity to, it's really difficult to speak, the necessity to have an interdisciplinary approach to the production of these coastal services. And I believe that really we need more detailed and large information concerning doesn't work concerning geological, ecological aspects, as well as the physical knowledge on the coastal dynamics. And in particular, for what concerns the needs of the local institution, as the region is, we need more information, more detailed and downscaled information concerning, as for example, the sea level rise, because we need to provide suitable forecast about what will happen on our coast in the future. And again, data concerning the sediment supply, because we have really difficult to collect information concerning the bed load from the river outflow and concerning the coastal and cross-shore sediment transport. Moreover, we need information about the ecosystem services and the problems linked to their loss. Again, economic information. So a lot of multiple information that helps to create really integrated services for the analysis of coastal risk and to develop forecasting due to climate change.
I would like to invite Professor Archetti.
Yes, so can you hear me?
Yes, we can hear you. Can go.
Okay, I'm the last, so I try not to repeat everything. So I agree with all what was told. I am a professor, so I think we need experts in these topics. And there will be, I guess, a lot of work for them. New expert in engineering, environmental science, physics, geophysics, and many others. Then I think that an essential ingredient in support for coastal resilience is to create methods with community dialogue and scientific research expertise in order to give some challenge. So, for example, I want to make some example. We want to build a consensus on gold with clear expectations. So, regarding the flood protection, natural processes, coastal habitats, cultural heritage. In the discussion, we need also to say which are the limits, because we speak about coastal resilience, but we hope that the public, the people, they are not expecting, they have to understand that something will change in the future, and the change will be very, very high. The science must drive the planning and the decision making to avoid any politics undermining of the effort. Then I think we have to account for the uncertainty. We have a lot of data also around this, about this, in the discussion, in the communication is very important to take into account, which we don't have our forecasting, our climate change scenarios. They are affected by uncertainties. We know that there are several of them, and so we don't know exactly what will happen. And okay, this is my comments to add to what I was already told. Thank you.
Professor Renata.
Yes.
Thank you. Now we're going to invite you individually to answer some questions. So, question for Perini. Could you please give us an example of adaptive management practices for coastal erosion and flooding?
Very much. So in Emilia-Romagna, we close. Okay. We face the problem through different aspects for what concerns preparedness and also defense. About the preparedness, we face the problem by developing and implementing the early warning system, and that still need to be better implemented also through more detailed monitoring, more detailed models, especially for what concern the storm surges, because sometimes we have problems linked to the forecasting of this kind of event. Besides, for what concern the management of coastal erosion and sea flooding from the point of view of the coastal defense, we already experimented for a long time the traditional coastal defense, especially breakwaters. We identified criticalities and benefits from these infrastructures, and having really encountered several criticalities due to the shifting of erosional hotspots closest to the areas protected and the lowering of the seabed, we finally decided to privilege the soft interventions such as beach nourishment, restoring of coastal dunes, and we also adopt temporary protection such as the winter coastal dunes. But we believe that besides this kind of intervention, we need also new strategy, such as to test new kind of intervention, as for example, those University of Bologna is testing, creating coastal reef that has to be tested. We believe in a very fast, because we need to determine new kind of intervention in order to protect our coast from, especially from coastal erosion. Because for sea flooding, the only thing is to hide the coastal dunes and to create the so-called I don't know in English. Anyway, we need to create artificial dunes immediately behind the beach. Other management practices, of course, are the early warning system and the measure related to the setback of the infrastructures present on the coast.
Thank you. And sorry for the noise, and for those who are on Zoom, I would like you to know that we are around many other events happening here, so that's why we have some background noise here. So now a question for Viviana. So today there is growing discussion about citizen science and the benefits it brings to the adaptive management of coastal areas. Could you share your experience with this practice?
Yes, we can bring a lot of examples on citizen science initiatives that are applied for coastal resilience and coastal monitoring. Because citizen science sometimes has an issue with the credibility, with the reliability of the data, while it's a very important data acquisition system. Because if we all repeated the same thing, we need data also for models, for forecasting, and also for early warning system that can be applied also for our safety. We have seen in these days a lot of flooding case in Italy, in Spain, in a lot of places. And in this case, citizen science can be applied at a lot of applications and a lot of levels. So we can apply citizen science for sure also to biological applications like cetaceans, visual census, or for example debris, plastics. But I work on low-cost technologies development. So if we have good low-cost technologies, we have said that sometimes we don't need so much resolution or accurate sensors to see something that is happening, like flooding. we need, yes, accurate sensor, reliable, and we could use these sensors for citizen science. And we have a lot of examples. One was cited by Giovanni, the Savannah, the Smart Sea Level Sensor Initiatives and Project is related to a community starting from the Georgia Tech scientists and engineers who developed a low-cost sea level sensor that, and they involved the municipalities, students, and citizens to install and deploy in this marsh area a lot of sensors that help them about the sea level rise and flooding. And we could do the same thing. We hope to do this with this one that we developed. It's a very low cost. But for example, this is for sea level. We have a lot of examples of initiatives of citizen science also for temperature. We know that marine heat waves are a very big issue. Now we can see from remote sensing, for example, but sometimes we have the effect on marine coastal ecosystem. We have example of the effect of marine heat waves on Posidonia australis, for example, that were completely removed and destroyed from marine heat waves. And for example, we have some initiatives from divers. We have the PADI organization with temperature sensors that are there on their watches, and they have millions of data of temperature, so we can take this data to have a lot of acquisition to be used, for example, by models or to have some data. So citizen science, for example, for sailing boats or sailing in general, the same. They can have a temperature sensor on their sails, and they could use during the cruises. They don't know they have, and they are acquiring a lot of data. They can be transmitted, and they also could be very good quality data that could be, for example, in our case, we directly put the data on EMODnet in real time, so we can have a really good way to have early warning system for this. So you have, you can detect and monitor a lot of data, and the citizen science initiatives are a very important contribution also for research, because they can give a lot of data that we can use for our health and also for the environmental safety. Thank you.
Thank you. Thank you very much. Now I invite Professor Archetti, which is online with us, to answer. So Professor Renata, how can coastal monitoring and forecasting help the marine green energy transition? And what are the new perspectives?
Okay, thank you for this question, which is very wide. Maybe it takes a conference to answer. So I think we need a good energy source assessment in order to start and to say how much can be the possible of renewable energy from the sea. And we need data for the resource assessment for wind, wave, currents, solar, and so on. We need data from the past in order to make the actual figure, and the forecasting in order to see what will change, obviously, in the energy production in the future. Then, of course, when a preliminary design choose what kind of machine, turbine, power takeoff in order to convert energy is decided, the project needs to go under the Scopus, the environmental impact assessment at the ministry, our environmental and energy ministry. So it means that the major environmental concerns are related to the increase of the noise level, which is a very important issue, the risk of collision, the changes to benthonic and pelagic habitats, alteration of pollution, scour, effect on the cost, a lot. So you can understand how many data we need for the energy transition. But just speaking about the new perspective, obviously, which are the possible future source of transmission. We already mentioned the wave, the wind, the currents, the solar. Obviously, I don't know if you are aware, the most important and the most promising is the wind, but not the onshore wind, the offshore wind. There are a lot of limits or characteristics. In order to have offshore wind farm, we need the proper depth, the proper soil, and there is a lot of research on the typology of the foundation, of the cables, anchoring, mooring, and so on. I give you just an idea. In order to reach the next goal for the Green Deal is by 2030. Italy, our country, will need to install more or less new wind offshore farm for 22 gigawatt. We don't have any. We have only a small offshore wind farm close to Taranto. And at the moment, there are under authorization at the ministry, we need 22 gigawatt of installation, 107 gigawatt. So it seems that this topic, this opportunity is exploded in our country, but then the work to be done, the finance to find, and the technological challenges will be really a lot. So yes, it's a very complex topic, and I think will regard a lot of teams and political aspect for the next 10, 15 years. I hope to have an answer in so short time. Thank you.
Thank you. Thank you, Professor. And now a question for Alessandro. Alessandro, in your work with EMODnet, you have focused on data sharing across Europe. What do you see as the main challenges and opportunities to continue and strengthen this European infrastructure?
Okay, yes. So I mentioned before that EMODnet is an initiative of the European Commission, DG Mare. It's funded by the MFAF. MFAF stands for European Fisheries and Aquaculture Fund. So I hate to break the poetry of this roundtable, but one of the first challenges is to secure funding to keep EMODnet alive. It's a very mundane argument, but this is quite important because the EMODnet has evolved a lot, relatively rapid evolution from a bottom-up network to the operational service that is today, and we serve more than 120,000 users per year. So you can imagine the amount of work that is behind this. So we've got to make sure that we can keep it alive. So this is quite important. On the issue of citizen science is amazing because I agree it's both a challenge and an opportunity. Of course, it's obvious that it is an opportunity. We can multiply the amount of data we receive by several orders of magnitude. It can be a challenge. I wouldn't mention necessarily reliability, but focusing on our work, we're going to need more guidelines to make sure that the data are fit for purpose. So it's not necessarily related to reliability, and we've got to be prepared to manage this huge amount of data, which is also potentially a challenge for us. And lastly, again on sensors, I mean, all in all, we do have in Europe a good network, a reliable. Everything can be improved, but in terms of sensors, samplers, we're not that bad, right? But we do believe, from our point of view, while the physical and chemical parameters are more mature, yes, the biological sensors, in general, we would need higher technology readiness levels, but more in general, stuff like this can be potentially a game changer, because we do need more cost-effective sensors. That stuff like this could really, really make a difference.
Thank you, Alessandro. Thank you. So a question for Coppini. Coppini, how do collaborative networks across regions enhance the effectiveness of adaptive management in coastal areas? Could you please give us examples of such coordination?
Yeah. So I had the opportunity and I was lucky to be part of the evolution that brought to Copernicus Marine Service. At the time I started, it was called GMES, and was, I'd say, started from the research community. So the research community is used to do across-region cooperation, and only through this cooperation today we have, of course with the support of the European Commission and ESA, we have satellite that fly and the system that gather in situ and produce ocean reanalysis, and I'm talking about the Marine Service and ocean forecasting, and is a totally coordinated system, distributed. So I think one aspect is that if you prepare it across cooperation, then you can build a distributed system, coordinated distributed system, and I think this was a European capacity and is now an excellence worldwide, because we can compare to US NOAA effort or to others. I mean, we are very strong in doing ocean forecasting today in Europe. Then this capacity, at least in the Mediterranean, was also developed through the Moon and Mongoose network. There were network where the Mediterranean, including the African countries and European one, were working together to really, let's say, build a system across scale, across, so still at the basin scale, but including national efforts. So that was really, it was a unique region, but it was many different nations cooperating together. Today we have the challenge of the coastal, global coastal ocean. So the UN Decade of the United Nations Ocean Decade offered the opportunity to build, and let's say we decided to go through this challenge to build a global network of coastal research institute and practitioners to develop together. Why together? So why across region? Because we need to develop, we need to include the indigenous knowledge, local knowledge in the solutions. We need to be replicable. So to demonstrate that your solution or our solution is effective worldwide, I think we need to test it in many different regions. And then we need to understand the difference of the problems from a scientific point of view, but also the commonalities. And we understood that there are a lot of commonalities. So that's why it's better to stay together. And for sure, if we stay together, we will go maybe a bit slower, but far beyond what we can do alone. So these are the main advantages. Of course, going back to what Alessandro was saying, we can mobilize easier the resources. The money comes when you join together, you work together even if it's not very easy to find money that allow us to cooperate at the international level, but there are funding opportunities, and of course they have to be done with the local community. We want to use this international cooperation capacity also to enhance capacity in the global south, and this can be done only through cooperation across regions.
Thank you, Professor Coppini. So a question for Kazu. So Kazu, could you please tell us how Castalia works to support coastal resilience?
Well, as I said, I mean, we provide the anti-pollution and oil spill response service for the Italian government. So we are directly involved in the protection of the coast, I mean, doing our activity every day. Our main challenge right now, as you know, it's the problem of the microplastics on the ocean. We have done so much, for example, facing the problem of the oil spills. And at the point that now all the incidents and the oil spills events in our seas are decreasing dramatically. And because of regulation, because of monitoring, because of a lot of activities during the last 30 years. And look, just a personal consideration. I come from Sardinia, okay, which is a beautiful island. I don't know if you know Sardinia, okay. It's a beautiful island with a beautiful sea. And I remember when I was young, when I was a little kid, actually, it was a quite normal experience to come back home with a stain of oil under my feet or on my swimming costume. It was very common, okay? After 30 years, 40 years, is not true anymore. Young kids, they do not experience that anymore, but they find plastics on the beach every day. So it's in their daily experience to find plastics everywhere. So now we are focusing on that problem because now that's the problem. And talking about data, experience, citizen science, we would like actually to share and make available our vessels, for example, to collect data and give you a feedback as well. So we can, I mean, cooperate. So that's why I'm very glad, I mean, we had this chance, I mean, to have this meeting. I mean, I think it would be a great thing, I mean, to find new ways and new solutions, I mean, for the coastal protection.
Thank you very much, Stefano. And now we're going to ask for Daniela. So could you please tell us how Planet Tech works in support of coastal resilience?
As Planet Tech, we are able to provide some solution based on satellite data. For what concerns the sea, I'm speaking about products such as water quality parameters, seabed vegetation mapping or coastline. And to specialize this product for a specific problem, putting together with the in-situ data and modeling. Just to do an example about the way to work, in this period we are supporting a worldwide entity that works for the sustainability, aquaculture and fishery in African and Southeast Asia countries. They need to understand which are the best places where to put new aquaculture plants along the coastline and also in internal water such as lakes. And for this, we are providing some information that are based on water quality parameters, on current, for what concerns the water, but also we are providing an analysis about the land side because they need not only to identify which could be the best place for these new plants, but it's important that internal markets are reachable. So we are providing some routes, best routes for doing this. Just to do an example. So starting from basic product, we specialize according a specific user need.
Well, thank you very much for this meaningful and insightful debate. I would like to ask the audience if somebody wants to make a question and to participate in the discussion. Yeah, and also Renata, which is online. Anyone? Professor? Do you want to participate? Yeah, talk about coastal resilience is very complex because we are talking about many types of challenges and disturbances as sea level rise, plastic pollution, and we need to prepare society for those and adapt.
Yeah. So a question is, have we forgotten something in our discussion? Are we forgetting, are we forgetting some point that needs to be included in science for coastal resilience? So do you have anything to suggest that we have forgotten to discuss during this time? Yes, please.
Well, I think that I would like to elaborate a bit on the role of the DCC, the Decentralized Coordination Center that we are running on coastal resilience, because what we have seen in Spain in the last week, it was a dramatic event, it was very difficult to forecast, but it was forecasted. The alert was given, but then there was we don't know all the detail, but there was a lack of communication and probably also a lack of capacity of receiving the communication by the population. I don't want to enter the detail because I don't know them, but somehow these events call for really working together, the society and the science community, the operational scientific community. So I think the DCC is called and us contributing to this type of centers that should spread around the solutions, the scientific solutions, and engage the society. So this engagement cannot go through projects, should go really on a stable way. And we need to engage more and more the civil protection into the science and the society into the civil protection, let's say, listening. So it's a complex system, and I think we have really a challenge in front of us, but we are on the right pathway. So let's say I want to understand with you how the DCC can grow, probably through training, through workshop like this one, make them more popular. School engagement is key. So citizen science and school, maybe working with EMODnet could enlarge even more. So, but we need to find a way of really penetrating the society from both sides. Let's say what is operationally forecasting should be improved, alerting should be more and more accurate, as Luisa was saying before. On the other side, we need the society really listen, also because at the end, the society needs to change. Because in Valencia, they will not rebuild as it was before, because it's doesn't make any sense. So the society has to find a way of changing, retreat. Luisa was speaking about maybe the coastline or the building has to retreat from the coastline because it's too risky, or from the river, or they cannot be too close to the river and so on. So, I'm calling maybe the colleagues here on a reflection on how we should maybe exploit our collaboration together in this sense.
I have a recipe. And thank you for pointing out the issue of getting the science to closer to the dissemination and the response, the preparation for better response of the society. We have preparedness and response. We have to prepare the society. And so we discussed this in Bangkok a few months ago. And they were asking, how can we make our population, that is very large population, aware of the issues that are dangerous for them to build, to make new investments and so. And I think that the science we started, but has to go to solve real world problems. So if the science solves real world problems, a little bit of mix between science and engineering that is needed, then we will automatically arrive to a better understanding by the different actors in the coast what is that they have to do and how they have to prepare themselves, how they have to plan, and so. Up to now, we have been very academic. Operational forecasting is one thing. Collection, new collection of data like EMODnet is a new thing. We have to continue to tell our students that solving real-world problems with good science is really, for the science part, an important message. It's not decreasing the value of science. Is the key to, for at least for coastal resilience, right? So this is my recipe.
Thank you, Professor Nadia, for contributions. Anyone else? No? Yeah, I totally agree. I would like to share my experience with you. I'm a scientist, but I'm also affected by coastal flooding. And where I live in Brazil, our building has an alarm. And when the alarm sounds and we have to leave and take off our cars off the garage, my heart beats so fast that I don't know what to do. It's like, and so we need to prepare people as well. So we have the science, we have the alerts, early warning systems, and people should know what to do. I saw during these floodings in Valencia, people getting into the car to drive out of the flooding. And nobody told them, just come on in my house. And don't go in the street now. You're not going to save your car this moment. Go out, shelter here with us. So we need also to communicate with people, so people should know what to do. And tomorrow we'll have a discussion in the session about education and coastal resilience. So I invite you all to follow our discussions tomorrow about education, which will start at 10 a.m. in the morning. So we have a full day. And I would like to thank you all for this afternoon, rewarding afternoon. Thanks to everyone who contributed. Professor Renata, which is online, our people who are on Zoom watching us. We look forward to welcoming you tomorrow. Okay? Thank you so much.
Thank you.